So let's look at the most basic of basic layer 2 switch. So no doubt you've seen one of these devices at your local Best Buy, or you've seen them on Amazon or another retailer around you. This is a very basic layer 2 switch, and what this essentially does is it puts all 5 of these Ethernet ports into the same local area network. So perhaps you've seen people refer to LAN switches and LANs and stuff like that. That's just a local area network, right? You might have one of these in your home, right? Where you have maybe an uplink to some sort of NATing device, and we'll talk more about that later. Otherwise might be known as a gateway. And then you plug in 4 computers into here. Maybe you plug your TV into one and your TiVo into another, and some other set of devices in the other 2 ports. But essentially everything plugged into these 5 ports is on the same local area network. So what exactly does that mean? So from a layer 2 switches perspective, so if we have 5 physical interfaces on there, and this is a layer 2 switch, a packet will go into here. And remember what I said before. What does a networking device really do in essence from a packet perspective? A packet comes in, and either one packet goes out, many packets go out, or no packets go out. The situation where no packets go out is either because of that packet is locally processed on the switch and invokes some upper layer application to process things, which then may later on cause packets to be generated and sent out some ports or all the other ports, depending on exactly how that switch is configured. In this case, these little $20 5-port unmanaged switches don't really do much, but take packets in one port and send them out either one or all the others. So it doesn't really process any packets locally. So either the packet comes in and it's going to go out one of these ports, or the packet's going to come in and a copy of that same packet, unmodified, is going to leave the other 4 ports. These 5 ports make up all the ports on a local area network from this particular layer 2 switch's perspective. Now, what determines either the red situation, where we see essentially 5 packets, 1 coming in, 4 going out, or the lime green situation, where 1 packet goes in and only 1 packet comes out? Why is that? So let's look a little bit closer at exactly what a vanilla layer 2 switch does. So when a packet comes in, so let's say it's coming in the port 1 over here. Remember, in a past video, I had a drawing of an Ethernet header. Well, for the most part, you can kind of ignore this with these very simple, unmanaged $20 layer 2 switches, and really focus on the 2 Ethernet addresses, or MAC addresses, MAC, media access control, more generic layer 2 designation. Come on. Oh, yeah. More generic layer 2 designation for whatever the protocol is at layer 2. For the most part, you're going to be running into Ethernet. We interchangeably call them the Ethernet address or the MAC address. So when a packet comes in, the processor, somewhere in here is a little processor, a little ASIC, application-specific IC, that will look at these 6 bytes. Remember, this is 6 bytes long, and determine, do I send it out just one port, output to one port, or do I output it to n-1 ports, where n in this case is 5, all of them. We never send on the same LAN, we never send a packet into and out of the same port. Are there exceptions? Absolutely. But in vanilla layer 2, we don't do that. We don't send a packet back to where it came from. So we're only going to send it out at most to 4 other ports. All right, Y1 and Y4. So when we look at this MAC destination address, we compare that address. We compare that address to a database that the switch keeps in what is called a forwarding table, right? So let's just make it easy here. Let's just say it has an address of hex A, all zeros, and then A at the end. And we look in this table, and in that table we have MAC addresses and the physical interface that MAC address lives on. So, going back up here, something out here sent that packet into the switch. The switch goes, okay, let me look at the MAC destination address. Where do I send it out? Let me reference my table. Do I have an entry for this address, this whole address? If the answer is yes, and it says, yeah, address A, 00000A, lives on physical interface port 4, meaning this one. That packet needs to be forwarded out to there. So, in this case, 1 came in, 1 went out. What about the situation where 1 comes in and many go out? Why does that happen? So let's draw another table here. So this is 1 in and n-1 out, or many out. So let's go back up to our picture here. Let's say a packet comes in and the MAC destination address equals all zeros and then 0B at the end. And so when this packet comes in with a MAC destination address equal to B, the ASIC looks at its table and it goes, I don't have an entry for B, so I don't know. I don't know where it lives. Let's send it out all 4 ports. So I'll redraw the switch here. A packet for B comes in and it goes out everywhere on the local area network. This is known as a BUM packet. And in this case specifically, this BUM packet is an unknown unicast packet because we don't know where B lives. It wasn't in the table. Hence, let me send it out to everybody. And then maybe I will then learn it later. And we'll talk about more about learning in a moment.